Okay, so we've looked at reflections, and we saw that we can take a graph and we can reflect it across the x-axis, flipping it upside down. We can reflect it across the y-axis, turning it that way. Now what we want to do is we want to look at what's known as shifts. So we're going to look at what happens when we change graphs like this. So to start with, we're going to take our x squared graph, and we're going to graph this transformation, x minus 1 squared, and also x plus 1 squared. We're going to do this first by plotting points. Now, the big idea here is we want to get to a point where we don't have to plot points anymore because it's a little tedious to plot points. So to do that, we're going to start by plotting points and see if we can't generalize what's going on here. So I picked a couple points for us to plot. So we're going to start with -1. When I plug -1 into -1 minus 1 squared, -1 minus 1 is -2. -2 squared is 4. So we get the point -1, 4. So -1, 4. When we plug in 0, we'll have 0 minus 1 squared. 0 minus 1 is -1. -1 squared is 1. So we have the point 0, 1. When we plug in 1, we'll have 1 minus 1 squared. 1 minus 1 is 0. 0 squared is 0. So we have the point 1, 0. And when we plug in 2, we'll have 2 minus 1 squared. 2 minus 1 is 1. 1 squared is 1. So we have the point 2, 1. Now when I connect the dots, I get something that looks like this. Okay? So our purple graph is the graph of f of x equals x minus 1 quantity squared. What do you notice about that graph? It's very similar to our blue graph. It's just kind of moved over 1. Okay. Well, now let's do the same thing, only we've changed this slightly. So now I want to graph x plus 1 squared. So the only difference here is x minus 1 quantity squared. Here I have x plus 1 quantity squared. Let's see what that does. Again, I picked some points for us. So when I plug in -2, I'll have -2 plus 1 quantity squared. -2 plus 1 is -1. -1 plus, -2, sorry. Wow, -2 plus 1 is -1. -1 squared is 1. So I have the point -2, 1. Sorry about that. -2, 1. Plugging in -1, I'll have -1 plus 1 squared. -1 plus 1 is 0. 0 squared is 0. So I have the point -1, 0. Now let's plug in 0. 0 plus 1 squared. 0 plus 1 is 1. 1 squared is 1. So I have the point 0, 1. And last, if we plug in 1, we'll have 1 plus 1 squared. 1 plus 1 is 2. 2 squared is 4. So I have the point 1, 4. Okay, it's getting a little crowded, but let's see what happens when I plug that in. Okay, it's getting a little crowded on there, but looking at our original graph in blue and our transformed graph in green, what do you notice? Well, it looks like this green graph moved to the left 1, whereas our purple graph moved to the right 1. So this seems to be a move left 1, and this guy seems to be a move of right 1. Turns out this is always the case. These are known as horizontal translations, or horizontal transformations, or horizontal shifts. So horizontal shifts mean we're moving left and right. Okay. And the thing with horizontal shifts is notice that what we're adding or subtracting is inside with our variable. And we're going to contrast that here in a minute to vertical shifts. Okay. So horizontal shifts are inside with our x variable, our horizontal variable. And the thing with horizontal shifts that seem to make people go a little crazy is they almost work backwards. Notice that -1 shifts us right 1, and +1 shifts us left 1. Okay. Now, I want to compare that to what happens when we add or subtract something outside of the variable. Okay. So let's flip over to this guy for a minute. Okay. And let's think about what happens if we do f of x equals square root of x. And now instead of adding or subtracting inside, I'm going to subtract outside. So notice the difference. As opposed to this -2 being inside with my x, like this -1 is, I'm subtracting outside. Let's plot a couple of points and see what that looks like. All right, so let's look at 0, 1, and 4, like we have before with this graph. Okay, so we're going to graph this guy. So when I plug in 0, I'll have the square root of 0 minus 2. The square root of 0 is 0. 0 minus 2 is -2. So I have the point 0, -2. Plugging in 1, I'll have the square root of 1 minus 2. Square root of 1 is 1. 1 minus 2 is negative 1. So I'll have the point 1, negative 1. Plugging in 4, I'll have the square root of 4 minus 2. The square root of 4 is 2. 2 minus 2 is 0. So I have the point 4, 0. Now when I connect the dots, wow, I really did not connect the dots well, I'm sorry. When I connect the dots, what do you notice? It looks like we've taken this graph and moved it down 2. So I've just picked up this graph and shifted it down 2. All right, well, now let's look at what happens when instead of subtracting here, I add. So let's look at f of x equals the square root of x plus, let's do 3. Okay. Now, let's take a guess. What do we think is going to happen here? Well, if this shifts everything down 2, seems like maybe this will shift everything up 3. Let's take a look. We're going to plot those same 3 points, 0, 1, and 4. Okay. When I plug in 0, I'll have the square root of 0 plus 3. Square root of 0 is 0. 0 plus 3 is 3. So I'll have the point 0, 3. Plugging in 1, I'll have the square root of 1 plus 3. The square root of 1 is 1. 1 plus 3 is 4. So I'll have the point 1, 4. Plugging in 4, I'll have the square root of 4 plus 3. Square root of 4 is 2. 2 plus 3 is 5. So I'll have the point 4, 1, 2, 3, 4, 5. Now if I connect the dots, I'll try and do it better than I did the last time. Here's what our graph looks like. It sure looks like we took this graph and shifted it up 1, 2, 3. Turns out that's what adding and subtracting outside of kind of our function here, the square root function or the squared function does. It represents a vertical shift. Okay. So that is moving our function up or down. Okay. And vertical shifts work sort of the way we want them to. Minus 2 shifts us down, plus 3 shifts us up. Okay. All right, we got a lot going on the board here. So let's take a look at this on Desmos. All right, so let's look at what we did. Whew. Okay, so we started by looking at horizontal shifts with our x squared function. So there's our x squared function, and we graphed, oops, f of x equals, first we did x minus 1 squared. Oops, geez, sorry guys, squared. And notice that that takes our red function and shifts it to the right 1. If instead we graph f of x equals x plus 1 squared, it takes our function and shifts it 1 to the left. Okay, so horizontal shifts. We're adding or subtracting inside with our function, and that shifts our graph horizontally. Okay, okay. Now, just for fun, what if, let's turn, so there's our original function. What if I change this to x minus 6? What do we expect this graph to look like? Well, this is a horizontal shift, and I should shift to the right 6. So I would expect to see this graph copied over here with a little parabola over here, shifted 6 to the right. Let's see if it is. It is. Okay, so there's our horizontal shifts. Now, we didn't graph horizontal shifts for our square root function. Let's go ahead and do that here. So here's our original square root function. Now, what would happen? What do we expect to, oh my goodness, sorry, my typing skills. What do we expect to happen if we do the square root of x and we do say minus 3? Well, our minus 3 is under the square root or inside with our horizontal variable. So this should represent a horizontal shift. Now the question is it going to shift 3? Is it going to shift 3 to the right or 3 to the left? Well, the answer is this is going to shift 3 to the right. Okay, so let's show that. So there we go. The square root of x minus 3 looks exactly like our square root of x graph. It's just been shifted 1, 2, 3 units to the right. Similarly, if we did the square root of x plus 7, what would we expect that to do? Well, this will be a horizontal shift 7 units to the left. So there we go. We've taken this graph and just moved it 1, 2, 3, 4, 5, 6, 7 units to the left. Okay, so horizontal shifts happen inside with our x variable, and they kind of work in opposite. Plus 7 means we're going 7 left. Minus 6 means we're going 6 to the right. Okay, all right, let's look at vertical shifts now. So originally when we did vertical shifts, we started with our square root graph, and first we did the square root of x, sorry. First we did the square root of x minus 2. Notice here, our -2 is not underneath the square root function, okay? When we did that, we saw that this graph was shifted down 2. Next, we did the square root of x plus 3, and we saw that that was our graph shifted up 3, okay? So vertical shifts work the way we want them to. -2 means down 2, plus 3 means up 3. And notice that the minus and the plus are outside of our kind of basic function, the square root function. So now let's give this a shot with our squared function. So if I start with f of x equals x squared, and I want to vertically shift this. So let's say we want to shift this down 5. How would I do that? Well, down 5 means -5, and notice that this -5 is outside of our squared function. So unlike our horizontal shifts up here, where we're adding or subtracting inside with the x, my -5 is going to be outside of that squared part. Now let's take a look. Yep, we sure took that green graph and moved it down 1, 2, 3, 4, 5 to do x squared minus 5. All right, now what do you think would happen if we did this? So let's do x squared plus 3 halves. Oh man, so we've got a fraction in there, don't worry about it. Plus 3 halves means we're vertically shifting, and we're shifting up. So I expect this graph to be shifted up 3 halves. In other words, it's going to go up 1 half, 2 half, 3 halves. So I expect the vertex, or this point here, to be right up here at 3 halves. Let's see if that's what we get. It sure is. So this is this graph shifted up 1, 2, 3 halves, or 1 1/2. Okay. Feel pretty good about those horizontal and vertical shifts? Okay, so now we're going to start combining those together. So let's start with our x squared graph. So there's our basic x squared graph. And I want us to think about what would happen if I changed it like so. Okay, so what do these things do? Well, notice that now I have both a horizontal shift and a vertical shift, right? This +2 represents a horizontal shift. So I expect this function to be horizontally shifted which direction? Left 2. So let me make this a note, sorry, it's gonna be easier for us to see. So I expect this guy to be shifted left 2, and what else? Well, this is a vertical shift, so I expect this to show down 4. So when we graph this, I expect to see this red graph shifted to the left 2, 1, 2, and down 1, 2, 3, 4. In other words, I expect the vertex, which is this kind of point where our graph starts, to be over here at -2, 4. Let's see if that's what happens. Yep, there's our vertex at -2, 4. Everything else is the same. So we can combine horizontal and vertical shifts. Let's try that again. So let's say I want to take our square root function now. So we're going to start with our square root function. Goodness. So let's say we want to take our square root function. So there's our basic square root function. And let's say we want to move it right 1/2 and up 5. Okay. How would we have to change this equation to move right 1/2 and up 5? Well, right 1/2 is a horizontal shift. Horizontal shifts happen inside kind of my basic shape, inside with the x. To go right, I'm going to have to subtract 1/2. And notice that's exactly what that did. That shifted our function right 1/2. So there's the right 1/2. Now how do we do up 5? To do up 5, we add 5 outside of our function. So the square root of x minus 1/2 plus 5 shifted our basic shape right 1/2 and up 1, 2, 3, 4, 5. Okay. All right. Now, just to kind of solidify this in our brains, I'm going to again take a function that we are not expected to know. We're not going to work with the cosine of x function. Okay. But cosine of x is going to work exactly the same way as it did before. So let's say we want to take our cosine of x function and we want to shift it left 2, left 2 and down 3. Well, in order to do that, okay, a left 2, that's a horizontal shift. So that's going to be +2, 2 inside with the x. Down 3 would be -3 outside of that kind of basic cosine function. right? This point here that was at 0, 1 has gone down 1, 2, 3. Can't count. 1, 2, 3. Then left 1, 2. Okay. So these transformations work even with weird functions that we're not going to be dealing with in this class. And that's really important to remember. We can combine transformations and they're going to work horizontal, vertical shifts, reflections, and when we add in horizontal and vertical stretches, we'll work with all functions, which is really, really great. Okay.